So let's start with the question in Vadim's collection. We call a phone number a beautiful if it is a string of 10 digits, where the ith digit from the left is at least 10 minus I, that is, the first digit must be at least 9, the second at least 8. So what this line here tells that we want to have a 10 digit number which would be beautiful if the digits placed here at the position I, ith position, is greater than or equal to 10 minus I. So for suppose if this is the position 1, then the number should be greater than or equal to 9, right? And at the position 2 it must be greater than equal to 8, and at the position 3 7, and so on. It must be at the position 9th, it must be greater than or equal to 1. So this is position 10th position. So at the 10th position the number should be greater than 9. So here is an example also given, that 9988776655 is beautiful phone number because here the number should be greater than 1, here the number should be greater than 2, 3, 4 and so on, and 9 greater than or equal to. So that is a beautiful number, while this is not, because the number must be greater than here at this position 8, and it is not, so this is not a beautiful number. Okay, Vadim has beautiful phone number. He wants to rearrange its digits in such a way that the result is smallest possible beautiful number. Okay, so we have to arrange the numbers in such a way that the number is formed minimum and it is a beautiful number. So how are we going to approach this problem? Okay, so the first line gives us the number of test cases. For example, here it is 4. The second line and the rest of the lines here, they tell what is the input number which we have to convert to the smallest possible beautiful number. Okay, so what we are going to do here, for suppose let's take the test case 1. In the test case 1, all the numbers are 9. So at this position number must be greater than 1. Here 2, 3, 4, 5, 6, 7, 8, 9. So the smallest possible number we can form is this only. Let's go to the test case 2. So let's take the second test case. So it is 9, 9, 8, 8, 7, 7, 6, 6 and 5, 5. 6, 6 and 5 and 5. Okay, so let's write the positions 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So at this position we are going to have the number greater than or equal to 9. Okay, 10 minus 1 is 9. So we'll take the number that is greater than or equal to 9. The smallest possible number that can fill this position here is 9, and 9 is present here, so we're going to fill it with 9. At this place, the smallest possible number that can fill this position is 8. So we're going to take 8 and we're going to fill here 8. The smallest possible number that can fill this position is 7. So we have 7, so we are going to put here 7. The smallest possible position number which can fill this position here is 6. We have 6, so we are going to fill 6 here. Okay, the smallest possible number that can fill this position is 5, and 5 is present here, so we are going to take 5. Smallest possible number which can fill this position here is 4, but we don't have 4 in the array. So what we are going to do is we are going to take the next number that can fill this position, that is greater than or equal to 4. We don't have 4, so we are going to take, what is the next greater element? 5. So we are going to fill 5 here. At this position we have 3, so what we are going to fill here? We don't have 3. What is the next greater element? We are going to have 6, so we are going to fill 6 here. So okay, 9, 10. At this position we have number 2. So what is the greater element that is present in the array? It is 7. 7. So we are going to fill 7 here. At this position is greater than or equal to 1. So what is the next greater element? It's 8. So we are going to fill 8 here. And at this position we have greater than or equal to 0, and we have the number 9 here. So we are going to fill 9 at this position. So what we did here is we iterated from the first position, took the number which is greater than or equal to the number to be filled at this position, which is smallest possible. Why smallest possible? Because as we fill here, like we filled here 9 and then we marked it as done, then we filled 8 here and we marked it as done, then 7, then 6, then 5, then 5, then 6. We form here the smallest possible number. Okay, because the positions which have the least possible number that can be filled should be filled with the highest number so as to make the number smallest. So that's why. How do we get a number which is greater than or equal to the next number, the smallest number, that is greater than or equal to x. How do we find that number? By the lower bound function. So we are going to use the lower bound function to find the element again and again which is greater than or equal to the number to be filled up at this position. So let's see the solution in order to know how we are going to implement that. So we are going to enter the integer t, that is the number of test cases. Then we have the string here in which we are going to input the number, the phone number. We have two vectors declared. This is for storing the answer and this is for converting the phone string into array form so that we can implement the lower bound function. Here we convert the string into array. Now we have loop which runs from 0 to 10. We have to sort the array num in order to get the lower bound from the lower bound stl function. The lower bound gives a pointer to the index in the array, and when we subtract the begin iterator from it, we get the index. So then we store the answer of I as the num of index, and then to mark it as visited we store -1 in place of it. Then we output the answer. So that's it. I hope you like the solution. Thank you.